Good afternoon to all my YouTube viewers. In this video, I like to discuss about interference of light. All the key points of interference of light listed in this video. In addition to that, we will solve at least 10 problems related to interference of light. The purpose of this video to boost students' performance as they need on fast track basis a preparation level so that they can do well in the exam. Also they have to participate competitive exams like Ydse mains and NEET medical exams. So, a solid materials is required to boost their performance. The effort is that. Now, we come to the subject. Wave optics, definition of wave optics, the shortest form, connection between waves and rays of light. Now, definition of wavefront, the locus of all those particles which are vibrating in the same phase at any instant is called wavefront. Now, definition of shape of wavefront. If it is a point object, point source, then spherical will be the nature of wavefront. If it is a line source, then it will be a cylindrical in nature. At faraway points, these same wavefront will become plane wavefront. Now, what is called ray? A line perpendicular to wavefront is called a ray. Now, Ydse's principle, there are at least 3 points on Ydse's principle, that is, every point on wavefront a source of secondary wavelets. Number 2, secondary wavelets move with a velocity of light. Number 3, all secondary wavelets under a envelope gives the new position of wavefront. Number 6, a Ydse wave theory successfully explains the phenomenon of interference, diffraction and polarization. Number 7, wavelength is inversely proportional to refractive index mu of the medium, that is lambda dash, we can write lambda over mu. Mu is the new medium and lambda is the initial source, wavelength of initial source. Now, come to what is superposition. The resultant displacement y produced by a number of waves is the vector sum of the displacements produced by each waves, that is y equal to y1 plus y2 plus y3 and so on. Now, what is coherent sources? Light waves of same frequency and same wavelength and have a constant phase difference is known as coherent sources. Then what is incoherent sources? Two sources of light which do not emit light waves with a constant phase difference are called incoherent. Now, condition required for sustained interference, at least 2 conditions are required. 2 sources of light must be coherent. Number 2, the amplitude of electric field vector of interfering wave should be equal. This is very important information, that we know light wave is an electromagnetic wave, and any optical phenomena means electric field take part in that phenomena. Electric field, not the magnetic field, electric field take part. So, that has to know. Condition for constructive interference. The basic requirements are, that is phase difference and path difference. If phase difference is twice n pi, where n equal to 0, 1, 2, 3, etc. Similarly, path difference equal to n lambda, n is 0, 1, 2, 3, etc. Now, condition for destructive interference, I mean dark fringes. Constructive interference means bright fringes and destructive interference means dark fringes. Now, here also phase difference and path difference. Here phase difference will be twice n minus 1 within bracket into pi, where n will start from 1, 2, 3, mind it, 1, 2, 3, not from 0. Similarly, path difference here also 2n minus 1 into lambda by 2. Again it will start from n equal to 1, 2, 3, not from 0. Now, come to resultant amplitude of two waves, that is A square, capital A square equal to component waves amplitudes, that is small a 1 square plus small a 2 square plus twice small a 1 small a 2 cos phi, phi is the phase difference. Similarly, resultant intensity we can write I equal to I 1 plus I 2 plus twice root under I 1 I 2 cos phi, phi is phase difference. Now, if I 1 equal to I 2 equal to I naught, in that case I will become 4 times I naught into cos square phi by 2. Now, I max over I minimum, that we can write root under I 1 plus root under I 2 divided by root under I 1 minus root under I 2 whole to the power 2. This is a very, very important formula. Many times questions comes from this formula. So, we have to get it ready for us. Next question, next point, fringe width, that is beta equal to big D by small d into lambda. Angular fringe width theta equal to beta by cap D, that is lambda over small d. And next 19th, that is nth bright position, that is y suffix n equal to big D by small d into lambda into n starts from 1 to 3. Similarly, for dark it will be position of the dark fringe, that is twice on the screen, that is twice n minus 1 within bracket big D by small d into lambda. Now, we like to discuss about problems on interference of light. Now, first question here, light waves propagates rectilinearly due to, there are 4 choices, wave nature, wavelength, velocity, frequency. Of course, the first one is answered, that is wave nature. Next question, the refractive index of glass is given, that is 1.5 for light waves, lambda is given 6000 angstrom in vacuum. The wavelength in glass is, there are 4 choices. Now, we know lambda dash equal to lambda by mu. From here 6000 over 1.5 it will give you 4000 angstrom. Inside the glass wavelength will decrease because it is denser material and it will be 4000 angstrom, that is the correct answer. Next question number 3, a galaxy moves with respect to us so that sodium light of 589 nanometer is observed at 589.6 nanometer. The speed of galaxies, there are 4 choices, we have to look for it. Then we know that c equal to n lambda, differentiating we can get d lambda by lambda equal to minus dn by n. Using Doppler shift, dn by n equal to minus d lambda by lambda equal to minus v radial by c. This is a very, very important relation, we have to know, because nowadays these questions come in West Bengal JE also. So, we have to be, we have to know it without any other point. Then v radial, we can write c delta lambda d lambda by lambda, putting all the given parameters, that is velocity of light, difference in wavelength divided by actual wavelength. Then we can see that it is coming 3.06 into 10 to the power 5 meter per second, which is 306 kilometer per second. It matches with the choice number B. So, answer will be B. Next, come to a laser beam is used for locating distant objects because it is a monochromatic, it is not achromatic, it is not observed. Number D, it has small angular spread, SPREAD, spread. Answer is D, because of it has small angular spread. Next question, number 5. When a low flying aircraft passes over it, we sometimes notice a slight shaking of the picture on our TV screen. This is because of between the direct signal and reflected signal. There are 4 choices. This is due to interference between direct and reflected signals. So, choice A will be the correct answer. Now, come to question number 6. The disturbance of Ydse experiment, phase difference is pi by 3, the intensity of the point expressed as a function of fraction of maximum intensity. Fraction of maximum intensity, that is I naught, is, there are 4 choices. We know I equal to I naught cos square pi by 2, I naught cos square, here phase difference is pi by 3. So, put it here and we can get I equal to I naught within bracket root 3 by 2 whole square, that is equal to 3 by 4 I naught. Question number 7. In Ydse experiment, the slits are horizontal. Intensity at a point P is 3 by 4 I naught, where I naught is maximum intensity. The value of theta is given here, the diagram is provided given here, that is S1 S2, distance between the sources is 2 lambda. Now, as usual that as we know I equal to I naught cos square pi by 2, from here we can put I 3/4 I naught. So, we can find out phi equal to pi by 3, which is phase difference. Now, we know standard formula, phase difference equal to 2 pi by lambda into path difference, and we know that path difference for this diagram you can see that d cos theta will be there, and instead of d it is given 2 lambda. So, we can put it 2 pi by lambda into 2 lambda cos theta. So, from this equation we can see cos theta will come 1 by 12, which is theta will be cos inverse 1 by 12, that will be the answer. Now, come to question number 7. 2 slits of Ydse have fringe width ratio beta 1 by beta 2, that is equal to 81 by 1. We have to find out ratio of the amplitudes A1 is to A2. Now, as we know, the beta 1 by beta 2 equal to intensity 1 by intensity 2 equal to A1 square by A2 square. So, we can put A1 square by A2 square equal to 81 by 1, which will give you A1 by A2 equal to 9 by 1. So, answer C is correct. Next question, question number 8. 2 coherent sources with intensity ratio is beta produce interference. The fringe visibility will be, there are 4 choices. We know I1 by I2 equal to A square amplitude square divided by B square amplitude square equal to beta, and A by B will be root under beta. Very important formula, that is fringe visibility V equal to I max minus I minimum divided by I max plus I minimum. Now, we can dump for I max, that is the A plus B whole square minus A minus B whole square. Solving this denominator also known, then solving this we can get 4 AB over 2 into within bracket a square plus b square. Take out b square and we can get final form 2 a by b and divided by s square by b square plus 1. Put beta for this a by b, then we can get 2 root under beta because a by b is root under b beta, then we can get 2 root under beta over beta plus 1. That will be the choice number D. Choice number A is correct here. Next is question number 9. Ydse used in monochromatic source of light. The shape of the interference fringe formed on the screen. There are answers: parabola, straight line, circle, hyperbola. Answer will be hyperbola. This derivation for this nature of fringe forms on the screen, this derivation is not in this 11-12 level, it is given in higher level, but you can accept this answer as a parabola. Next question, question number 10. Now, in a Ydse, the source is white light. One of the holes is covered by a red filter and another by a blue filter. In this case, there are 4 choices. There shall be a alternate interference patterns of red and blue. Number B, there shall be an interference pattern for red distinct from that for blue. Number C, there shall be no interference fringes. Yes, this is the answer. C is the answer. When different colors, different wavelengths, different frequencies are present in the component waves, it cannot produce interference fringes. This is very important information. Thank you very much. I like to tell you that you should share this video to others, so that other people can also improve their performance, and you can like it, you can share, you can subscribe. If you fail to subscribe, you subscribe, so that I will be much more motivated than what I am doing today. Definitely I am going for extensive preparation practices will be developed through these videos, through this channel. Now, thank you very much for listening.